And when you look at that y equals in number 15, and kind of all of these in that last column, when you look at those, as you're solving for y, we already have 2y by itself. So what you only have to do to finish the problem is divide by 2, which means y is equal to 7 over 2x. Someone said, well, isn't that the same as 7x over 2? Yes. But notice that these answers, they take the x kind of, and it's always the fraction or number times that. Remembering that this would be the same as 7 over 2x plus 0. Same with these down here. If there's nothing there, that's like a plus 0. So this was your answer, okay? Overall, I think after doing this worksheet, it kind of gets a little better with the y equals. So today we're going to be looking at this next part. So if you turn in your notes to literal equations. Literal equations, we're going to watch a short video with what is a literal equation. The gal's voice sometimes, like possibly my voice to some of you, gets like a really loud at some points. It's not quite as bad as the commercials on Channel 1, but it does get loud. And so I try to watch the volume, but it still sometimes comes through. So, as you watch this video, what I want you to be thinking about is, what is a literal equation? Because it's asking you to write that definition here. So that if you were going to define, and you will hear it in the video, Aaron, turn to the front, please. You're going to hear it in the video. They tell you that there's really 2 things that make a literal equation. One, but then they say, and sometimes it's written like this. So as you watch this, think about as you are watching this, and as you look at this, like I said, so these are some that you might see, and it says, what is a literal equation? As you look at these right here, this is kind of like what we were doing. We were solving for y. And so these are some different types of ones that you might see.
Let's learn about literal equations. If we take a look at the name, it looks like a literal equation is a type of equation. And that's right. Now, an equation identifies a relationship between the left and right-hand sides of the equal sign. Now, to help us see a literal equation, let's go ahead and explore some equations. So let's write a few equations down. Let's say we have this, x plus 8 equals 12. This is an example of an equation. We have a left and a right-hand side of the equal sign. Here we're saying that x plus 8 is equal to, or the same as 12. We're saying that the left side is the same as the right side. Now, we can also have something like this. 7x equals 21. Here we're saying that 7x is the same as that right side 21. Or we could even have an equation like this. Y over 2 plus 5 equals 7. This is another example of an equation. Now, all of these are typical equations that you might see. There are also some other equations that you might see as well. Let's take a look at those. Let's say we have 3x plus 2y equals z. Here we see we do have an equation, but it's a little bit different from the ones we just saw. Notice, this equation has 3 variables, x, y, and z. All of these equations only have 1 variable. Now what if we had an equation like this? D equals r times t. This is another equation, but notice, this one just has variables, 3 variables, and no numbers. Or what if we had something like this? A equals 1/2 times b times h. Here again, we have more than 1 variable. Now, each of these equations that has more than 1 variable gets a special name. These equations are called literal equations. A literal equation is an equation that has more than 1 variable. So, each of these equations, these literal equations, let's go ahead.
So you got the definition down? Literal equation is an equation with, what would you say? More than one variable. You're going to see some examples of different ones as we look at
And
those.
take a look at some more examples. The most common type of literal equation is a formula. So let's look at some of those. Here we have A equals L times W. We can see this is an equation where the left and right hand sides are equal. And we have more than one variable, A, L, and W. So this is a literal equation. This is actually the formula for the area of a rectangle. In this formula, A stands for the area, L stands for the length, and W stands for the width. Now, usually with formulas, we're given values for some of the variables, and we need to solve for the unknown variable. So say here we were given the area and the width, but we were missing the length. Well, in that case, we could plug in the values for the variables that we had, and then solve for the unknown variable, like L. Neat. Now, we can also have one like this. I equals PRT. This is a literal equation. It's the formula for interest. I is interest, P is the initial amount that we invest, R is the rate, and T is time. Or we could even have a literal equation like this. P equals 2L plus 2W. This is the formula for the perimeter of a rectangle. P is the perimeter, L is the length, and W is the width. Now, we can also have literal equations that look like this. Y equals mx plus b. This is a literal equation. It's actually the slope-intercept form for a line. Neat. Or we can also have one like this. Ax plus by equals c. Another literal equation. This one is the standard form for a line. So now we know more about literal equations. If you have an equation that has more than one variable, you are looking at a literal equation.
So as we look at that, and we are looking at a literal equation, all we have is an equation with more than one variable. Did we solve those today? For y and x, right? We had y and x in all of it. You solve for y, you solve for x. So more than one variable. And you have already done these questions, okay? And some of them are going to look, the first ones when we start out in our homework, ask you to solve for x again, okay? So we've been doing a lot of the solve for y. More than one variable. The other thing that I like to think of it is it's usually your formulas. And if you take a look down at all of these formulas that you are given in that next part of your notes. So these are just some of them. Last year you might have also done area of a trapezoid, right? That formula was area equals 1/2 height, and then you did base 1 plus base 2. There might be other formulas that you might be thinking of. One we're going to use this year is when you calculate your interest. You do that by taking the principal times the rate times the time. We're going to use that formula. So those, and there are other ones. I don't know if any of you know the conversion between Celsius and Fahrenheit when you change temperatures. There's an equation that they give. And those are some of the different ones that we're going to look at. So this is the one with the Celsius Fahrenheit temperature. And we're going to be using some of those. And what they're going to ask you to do is to solve for one of these variables in the equation. So it's going to kind of be like solve for the y or x. If this is our equation on the top of the next page, area is equal to, this is a literal equation, and they are going to ask you to solve for L in this case. So I have L times W. If I have L times W means I want L by itself. I need to divide both sides by W. And my answer, I'm simply done with putting L equals. Use the capital A if it's capital, and use lowercase w if it's lowercase, divided by W. And you're done. That's all you had to do for that one. Okay? This one is a little more involved, right? When I look at that fraction, 5/9 being times that parenthesis, that's the first thing I want to get rid of. So anytime we have fractions, we want to get rid of them. So what do I have to take times? So I have C on this side equals, what am I taking times that 5/9 to get a 1? Raise your hand. What are we looking at, Stacy?
The reciprocal.
The reciprocal of 5/9. So I want to multiply by 9/5. Someone had mentioned earlier, couldn't you just multiply both sides by 9? That gets rid of the 9. It doesn't help us get rid of the 5, and we want to get rid of both of those, okay? So that now when I multiply this would have been 45 over 45, or just 1. So I now have 1 times f minus 32, right, is equal to 9/5 times c. Take out your calculator if you need to, or some of you might know. 9 divided by 5 gives us what decimal? 1.8, right? And we're going to leave that with c. Why would I want to change it to a decimal? Because a lot of us can think of taking 1.8, it's really close to 2, rather than when some of you think of 9/5, you kind of have a harder time picturing that that's really close to 2, or that it's 1.8. So this really is 1.8 times c equals f minus 32. I need to get the f by itself. We're trying to solve for Fahrenheit. Malcolm, what am I going to do to get f by itself?
Plus 32.
Plus 32. Do it on both sides of your equal sign. Now on this side, this is not going to become 33.8, right? We're going to leave this as 1.8c plus 32 equals f. So if we are looking at that, this is what f is equal to. Why is this an important thing to notice? I don't know if any of you have ever traveled out of the country. And if you do travel out of the country, one of the things you're going to notice is that almost everywhere besides the United States, they give the temperature in Celsius. Almost everywhere. You go up to Canada, you go to Mexico, they always say this many degrees Celsius. So if I would tell you that right now outside the temperature is at a negative 12 degrees Celsius, and I said, how many degrees Fahrenheit is it? What we would want to do, and we're going to approximate it. So 1.8 is about what? 2. So to find the Fahrenheit, we're going to say 2 times negative 12 plus 32. 2 times negative 12, this is easy to do in our head, right? Negative 24 plus 32. Our temperature outside should be about 8. Is it probably a little less than 8 or a little more than 8, would you say?
It's 8 degrees right now. I just checked my phone last night.
Really?
Yeah.
Why are you checking your phone? But
It's
anyway,
always
besides that.
earlier.
But it's good to know how cold it is outside if you're checking. So when we are looking at that, that's the conversion. It's like 2 times that approximately plus 32. So if you're traveling someplace or you're going someplace, that's kind of a neat conversion to just think 2 times whatever the Celsius and add 32 if you can remember it. But that's where formulas come in very useful. Many jobs use formulas to calculate different things, okay? This one is for interest. So if you take a look at this equation, okay? As we take a look at this equation, we have I is equal to, and they're asking us to solve for R. It says P is the dollars we invest. R is going to be an interest rate. Usually interest rates are going to be a percentage, okay? And it says T is our years, and we want to solve for R. All of these are being multiplied. They just don't put multiplication. It's P times R times T. So if I want to get R by itself, what do you think I should be dividing by on both sides? Raise your hand. What do you think, Jordan? P and, not R, but P and T. So I get P and T. So if I am looking at solving that, my equation R would be equal to I divided by capital P times T. Now, that comes in very nicely in this part because they are telling us, okay, let's look at this and let's solve for and plug in the numbers. So we are gonna do that. We're gonna plug in the numbers. So if we are doing that, we're gonna start off with R equals, what is our interest? In this one, 54 is our I. So we're gonna put 54, because we're following right from here. I equals, what is my P? That means how much money I invested. This is my principal, and I get 1,500. And it's times 1 year, so that would be my T times 1, which really means we're taking 54 and dividing it by 1,500. So please take out your calculators and tell me the decimal you get for our rate. What'd you get, Greta? 0.036. Now, you usually will not see a bank saying, hey, the interest rate is 0.036% for you to save your money here. You are usually going to change this decimal to a percent. So we would want to say that our rate, if this is our decimal, our rate, changing this, would be 3.6%. Okay? And most times in math problems, what they'll do is they'll put the percent, or they'll change the decimal to a percent, or if they start with a percentage, they'll then change it to a decimal. All right. Anyone want to volunteer as we look at this next one? We're looking at using the literal equation. Radius, go ahead, Rita.
Also, you want me to read it? Okay.
Yeah.
What is the radius of a circle with circumference of
64.
feet? Round to the nearest 10. Use 3.1445.
First thing it says, choose the right formula. They tell us circumference. So if you turn back to that first page of your notes, if you don't remember from last year, circumference is equal to, the formula is, no one want to read it? 2, and this is times pi times r. We are trying to find the radius. That means I want r equals, okay? I'm trying to get r equals, which means in this case, if I'm looking at this equation, Robin, what might I do to get the r by itself then?
So we would choose to 2 pi. Yeah.
Divide both sides by
2 pi.
2 pi. We divide both sides by 2 pi. So when I write my formula, I put r equals, and I like to put the variable that I've solved for first instead of behind. And then I have c, which is my circumference, and it is divided by 2 times pi. Now they just told us that the circumference in the problem was 64 feet. And they said use for pi, not the pi button, they said use 3.14. So we want to plug in 3.14. So when I put this in my calculator, I am really looking for 64 divided by 6.28, correct? What am I getting when I put that in my calculator? Please do that and raise your hand before reading out for us. 10.19. But then our answer says round to the nearest tenth, so we would say our radius would be 10.2, and we need a label with it, just like in the beginning of the year. When we're looking at our story problems, you got to tell me what we're talking about, not just r equals 10.2 feet. Okay. One more page of notes that we're going to look at. Actually, one more slide in your notes, and then we're going to get you started. So, if you're going to read for us, go Robin.
Well, the monarch butterfly is the only butterfly that migrates annually north and south. The distance that a particular group of monarch butterflies travels is shown. It takes a typical butterfly about 120 days to travel 1 way. What is the average rate at which a butterfly travels in miles per day? Round to the nearest mile per day.
First thing we are asked to find, what is the average rate? So of our 3 variables here, distance equals rate and time, we want to find what r equals. Which means, Kennedy, what should I divide both sides by, possibly? Divide by t. So we're trying to find what r equals. R at this case is equal to the distance divided by our time. If I'm looking for the distance, Haley, what was our distance? How many miles in our picture? How much? 1,700. So I'm going to take 1,700 miles. And Maya, what was our time period that they told us when we were reading? Right, so this is divided by 120, right, days. Our answer, when we look at that, our rate is going to be in so many miles per day. And when you did the division, what'd you end up with, Elizabeth? 1,700 divided by, so if we are reading it and it says to round it, so the 14 point, what'd you get? 1/6 repeating, and it says, but round it to the nearest mile per day. So you would tell me our butterfly is roughly getting 14, right, miles per day. So sometimes all those extra decimals, we don't really want to put those in, so we're going to leave our answer in that form, okay? Your homework tonight. The first 8 questions are just like you've been doing. Only thing they don't say solve for y, they say solve for x. We're going to do number 1 together, and then I will let you pick one other one that you would like to do besides 1. So, turn in your workbook to 1. You have 12 questions. It's only on the 1 page, right? So, that's why I didn't want you to do the work on the joke sheets. It's just this page. So, in number 1, if I'm trying to get x by itself, Christelle, what are you going to do first to get that mx by itself? Well, not divide by b, but I want to, how do I get rid of a plus b? I want to subtract it first. When I do that, on that side of the equal sign, Devin, what am I going to be left with? Y m times x. Natalie, next step is I want to know what 1x is. What would I do now? I have m. I don't know what number m is, but it's a number like out in front. Divide every single thing by m, because my goal is, and then what I would like you to do is kind of circle your answer. So x equals, we're going to say y divided by m minus b divided by m. And you're going to leave it like this. It's ugly. You have lots of letters in both numerators, and you're going to leave it like that, okay? So that as we are looking at these, if I would have told you what m and y and b were, you would substitute in, Sam.
Can you say x equals y minus b over 1?
No, I don't want you to put it all over m. I want you to divide them up. I want to keep them separate as you're looking at those. Okay? Number 6, is that choice? Everyone okay doing number 6?
Actually, no, we should do 2. Yeah, let's do 2. Let's do 2.
2, 6, 3.
No, let's just do 2, because that one looks hard.
Okay, so here's the hint with 2 and 6 is kind of similar to it, okay? And 4 is kind of similar to that, right? Because they all have fractions. So 2, 4, and 6 all have that fraction. If I want to get x by itself, this is x divided by a. What can I multiply by to get rid of this a in the denominator?
A over x.
A over just 1. Just a over 1, right? And on this side, I have y over b, and I'm simply, again, multiplying it by a over 1. Remember, whatever you do on one side, you do on the other. Now, what would you want to multiply in 6 on both sides? B over 1. This one, you first want to get this by itself, and then you're going to multiply kind of like number 2. So when I look back at number 2 now, and I'm simplifying a over a, that's 1x. That was our goal, right? All of these, we're trying to find 1x equals. What do I have left? Yeah, ya over b. That's my answer. X equals y times a. Does it matter if you put ay instead of ya? No. That is my answer that you're going to search for. Okay? Let's look at the bottom half. It gets looking a little uglier.
Yeah, this looks really ugly.
It does.
Let's do 12.
Let's look at a 9 first, because you're going to start 12 the same way as I'm going to start 9. So, if we start with one a little easier before I break into the harder one, then it'll kind of give you a hint, and then I want you to attempt 12, but if you don't get it, I'm okay with you having just 9, 10, 11. So in number 9, first thing is you have these fractions here, same thing in number 12. What am I going to multiply by on both sides to get rid of that fraction 1/2? 2 over 1. So start with the second step down, putting 2 times capital A, right? If it's capital, keep it capital. If it's lowercase, keep it lowercase. Someone said, can't I switch back and forth? Usually the A or the capitals are for like area, volume, different things, okay? Whereas the lowercase, those are for side lengths, okay? So here we're taking 2 times 1/2 BH. My hint is when you start this problem, you start it the same way. You take 2 times the capital A equals 2 times, okay? Well, what happens when you take 2 times 1/2? It equals 1. So I have just BH on this side, right? Base times height. This canceled, that's 1. I'm asked to solve for B. Next step. Kennedy. Divide by H, because we want to get B by itself. Would we say this is what B equals right here? 2A divided by H? Yeah, because this is going to be the 1 over 1. Okay? Tomorrow, or Monday, not tomorrow, I'll do
I have a question. Does it matter if you use the B or the H ever?
It would matter because the H is telling us the height here, and this is a base. Okay. So notice this one, it asks you to solve for B sub 2. Try it, but you should be able to do these two. So when you come in Monday, just like when we did the Y equals, we did 2 days of that Y equals. We did a second day of practice. I don't know if you've looked at your notes, but your notes for this, they kind of say, oh,